name is Mehmet, and I'm the president of Takam High School chapter. Today, we're going to have a webinar where 4 computer engineers are going to speak and give their experience and insight to high schoolers. I'm in the car right now, so it may be tough to hear me, but we can assure you this is going to be a very informative and fun event. But so without further ado, I'm going to hand it over to Eren Okuyucu, Takam High School chapter vice president. He's going to start off with the speaker introductions.
All right. Hi, everyone. My name is Eran. And so I'm going to be introducing you guys to the speakers. Up first, we have Alp Okuyucu. Alp Okuyucu was born in Wichita, Kansas, and raised in Southeast Michigan. He earned his bachelor's degree in computer engineering from the University of Michigan in Ann Arbor, Michigan in 1993. He began his career as a software developer at Production Modeling Corporation in Dearborn, Michigan, before joining PTC Incorporated in 1999 as a software pre-sales engineer. He is currently a consulting fellow leading multi-million dollar implementations of enterprise product lifestyle management software for a variety of customers across multiple industries, including medical devices, heavy industry, and the Department of Defense. If you have any opening remarks that you would like to share with us. You're muted, but I think you just said no. So up next,
that was well done reading the bio. Good job.
Thanks, Dad.
No problem.
Next up is Miss Banu Arslan. Banu Teyze was born and raised in Turkey. She graduated from Istanbul Technical University with a Bachelor of Science in Food Engineering degree in 1996. As was every engineer's dream at the time, she came to Eastern Michigan University to get her MBA. During her studies, changed majors and graduated with a master's in information systems. She currently leads a team that empowers Flagstar Bank to help reach their goals using the company's public and internal websites. Banu Teyze, if you have any opening remarks.
No, you summed it up.
All right, cool. And then next, Miss Melis Öner. Melis Teyze was born and raised in Istanbul, Turkey. She graduated from Istanbul Technical University, Electrical Engineering Program, and Istanbul University Conservatory Classical Guitar Department. She started programming in ITU's Solar Car team, where she helped Ariba.
Benim hiç internet connection'ım yok. Ne yapıyorsanız çıkın.
Pardon. She helped Ariba 4 to win the Best Newcomer Award in World Solar Challenge 2011. She worked as an Android developer, DevOps engineer, and web application developer in both automotive and healthcare industry. She published papers in IEEE conferences during her master's degree at Central Michigan University. She is a graduate of the Young Scholars Program of Global Relations Forum, where she is still occasionally participating. Mrs. Öner, do you have any opening remarks?
It's nice to be here.
Awesome. And then last but not least, Mr. David Kaczynski. David Kaczynski is a machine learning engineer at the world's largest mortgage lender, Quicken Loans. David started with building simple websites in middle school and learned beginner C++ and Java in high school. In college, he majored in computer science, specializing in software engineering and data science. After college, David worked at General Motors to help solve problems using big data and AI, such as testing collision warning systems and training autonomous vehicles. Today, David builds data pipelines and user interfaces for Quicken Loans bankers to match the best mortgage products with the right homeowners. Mr. Kaczynski, if you have any opening remarks.
He'll be here very soon.
Oh, okay. Well, when he comes by, he can do his remarks then. But yeah, so now we're gonna start with the questions. So up first is Ozan Uylur from Huron High School.
Hi, my name is Ozan Uyulur, and I'm in 11th grade and I attend Huron High School. And my question for you guys is, what branch of computer engineering are you in and what do you do?
Eden, are you going to call on us or do you want us to just speak up?
Oh, you guys can just speak up whenever. Just make sure that you limit it to 1 minute per answer, please, just so that
Yes, sir.
we keep it in time. Yes.
Yes, sir.
But yeah, you guys can go in any order that you guys choose. Just speak up whenever.
Okay. So since I'm the oldest one, I'll go first. So I made slides, but I'm not going to share them. I'll send them to you guys later. So I am. What branch of computer engineering am I in? So I could be best described as a software engineer, although my primary job is consulting. I started off doing basically programming work, application development, that sort of thing, and then moved to PTC, like and then so expertly read in my bio in 1999 to essentially do software development within a pre-sales role. So PTC is a company. We manufacture, or we write and we distribute and we sell enterprise software tools as well as desktop CAD tools. You may have heard of some of it, but essentially we had just branched out into enterprise PLM software at the time. So when I joined them, I went in as a developer and then moved over into consulting, and then through various leadership roles, and now I basically am a consulting fellow. So I still do some hands-on programming, Ozan, but it's a lot more technical management, technical design, customer service, obviously, and some implementation and development. Next.
So I'll go next. When I graduated, there were 3 options in front of me at the time with the Information Systems Masters. It wasn't geared toward management, so it was more either you go to network engineering, database administration, or software engineering. So I chose software engineering. And that's where my heart was. It doesn't mean you don't need to know the other 2 areas because you interact with every other database or everything in the network, inside and outside. But that's where I'm at. Next.
So we're answering what branch and we are in computer engineering.
Hi, sorry about being absent for a minute there. I'm David. I understand I was already introduced. My experience was actually just like Banu, if that's pronouncing your name correctly.
Yeah.
I started off programming in high school, doing.
You have 1 minute.
Yeah. Okay. Yeah. So I had some exposure to like website stuff, but my university also had specializations in software engineering, networking, and databases. So it really just depended on what type of problems you wanted to solve. And software engineering was more of like the organization or people side of things. So that's what I was kind of interested in.
I'm going to go next. I started with embedded development, mostly like programming microcontrollers with like low-level language C. And then I was more like opportunistic. Like I studied electrical engineering. So whatever opportunity kind of presented itself, it was Android development. And then I did a little bit DevOps, and now I'm in web application development. So software engineering.
All right, thank you guys. Next speaker is Eja Uyulur from Y-High.
Hi, I'm Eja, and my question is, what is your usual workday like?
For engineers, should we all go in the same order? Because
sure, do that. It'll be easier.
Yeah.
Because that's what we're used to. Yeah. So my usual workday is when I thought about this, it made me really sad. So it's probably at least 50% meetings, probably more like 75, 80% meetings. and then you get the rest of the time to do actual work. System design is what I do, system architecture, and then I'll test, like a build, or I may even, do a little bit of hands-on myself, some implementation, problem solving, whatever. How do we solve this in the software? Whatever the problem du jour is. But honestly, it's a lot of meetings, and the meetings are all about, planning and direction, and, giving and getting and providing direction, meetings with the customer, internal meetings where we're trying to figure out what we're going to do next. So I know it, don't let that depress you though, because then the times when you actually get to write some code is really fun, and it makes it that much more interesting. But yeah, that's mine.
All right, I'll go next. I guess unfortunately we're somewhat veterans of the industry. At least Alp and I, we have moved on to different roles. But when I started as a web developer or software developer, it was mostly development. We had some meetings with the customer, but not so much. We were working with project managers, business analysts that would give us what we need to do, and then we would demo it to the customer. But at this time, I work for a financial institution, and even though I'm not in the, I'm not doing banking per se, I still do, go about my day 8:30 to 5. We have some meetings with the customer, demos. I have to coordinate coordinate with our QA analysts, developers where they are having problems. I am the go-to person at this moment to resolve issues if they need, help from external IT units or external customers. My customers are not external customers of the bank. My customers are all internal. So at this moment, it's a lot about meetings and then very limited development on my end. But I'm the problem solver.
I have a question.
Sure.
Yeah, so actually it's a question for all. I think I already asked that on the chat, but what is the most frequent programming language you guys used? Like Java, C#, or what is the most frequent one?
Flagstar Bank is a Java house, so we have been using Java.
Java, I see. And how is the impact of COVID-19 on the IT industry?
We flipped to working from home right away. We didn't spend, any time waiting around or anything. So, no impact on us. We miss each
like
other,
creating jobs or something like that.
It did, yeah. It definitely flourished. Like my company had one of the most profitable quarters last quarter. I think because of like having to work from home, this, I'm sure you heard about the cloud systems. Like how I define cloud is mass production for software development. Like that's what it enables in a way. And a lot of companies like needed that so much more, and IT created more jobs, and it actually became so much more profitable.
Thank you.
Yeah, I would agree. I think with COVID, just in terms of a work perspective, yeah, absolutely. I work from home anyways, so no change there. But in terms of like the opportunities, we had a product that, so we get into, we're getting into branching into AR. We have been for several years into, augmented reality and other, kind of newer technologies that I would call them newer. Some people probably think they're old, but anyway, with augmented reality, we had a product called Vuforia Chalk, which was kind of it's a thing, you've got it on your smartphone, so you can call somebody else that has the application. And then if they're trying to do something like, I don't know, change the furnace air filter, right, is a nice example. And you want to kind of walk them through it. Well, they can, they can hold up their phone or their iPad or whatever, and you can draw on the screen, and they'll see what you're drawing, and hold it there. Okay, now pull the old one out and make sure you note which way the arrow is pointing on the filter, and then grab the new one, make sure the arrow is and you can just mark up and do things like this. So my company PTC actually made that available free for people to download and use. It's a product we sell and market, but with COVID, and everybody being remote, we thought that was a way to kind of introduce ourselves, but then also provide some benefits. So and there was some development. Obviously, R&D is constantly churning out new versions, but I can send my slides around. I've got a link to it as well. But if you guys are interested, before you expert capture, it's pretty cool, and I think it might still be free. So like, if you want to show, I don't know, what's like the highest value Pokemon card and how to play it, right? You could use expert capture with a friend who doesn't know, for example. Sorry, I think you guys wanted to say something.
Oh, no.
I was encouraging him to answer the language question because he's using a different stack.
Yeah. Yeah. I mean, you'll find a lot of stuff, obviously. There's Java shops. I'm at Quicken Loans, and there's kind of two sides to it. On the product side, where it's all the customer-facing stuff, it's mostly C#, .NET stack. And then on my side, I'm on the data science side, so it's mostly Python. So,
yeah, it also really depends on where you work. I'm also in consulting. It's mostly the focus is on enterprise software, which is mostly Java. But I also work as a small software startup where we use JavaScript everywhere, front end, back end, even the data layer to a degree. Yeah. So just to confuse you a little bit more.
Another question I would like to ask is, any of these companies worked on operating system development?
No. Operating system is something work.
I see.
Basically, you can do your open source Linux or go work for Apple or Microsoft. I mean, I think that's about it.
Yeah.
It's not something you tinker with. You either make operating systems or you use someone else's.
Yep.
Yeah.
Mostly for like maintaining the operating system, or additional things like for the iOS or something like that, because some startup companies making applications for Apple, and then they are selling to Apple, and they add it as a feature.
Well, I mean, maybe there's a difference between like app development and then because I don't know the iOS ecosystem too much, but I know Google will buy an app and then turn it into their app. Like they'll, things like that. But actually contributing to the operating system, that's, I don't know if another engineer can speak more to that. Any operating system contributors?
In one of my first computer engineering classes in college, they made me rewrite parts of Linux or Unix. It was Unix at the time. Yeah, that was painful. Yeah. So if you can avoid that, whoever asked that question, I would highly encourage you, unless that's what you want to do. And it's ugly. Apple's proprietary anyways, I think. I don't know that you can even get at Mac OS if you wanted to.
I mean, all this to say, if you did go in that direction, there'll definitely be opportunities for you.
Yep.
But it's rigorous. It'll be rigorous.
Yeah, it is also really like a side job for a lot of people. There are open source repositories that you can go work with people that you'll never probably meet in person, and they mostly work on those in the evenings because they don't make money. It's open source, but then you can build your skills and you can become more marketable with doing that. But I don't really see a path of making a living with it for a while. Yeah.
Agree. Next question. Or Banu, did you want to answer that one as well, or?
No, I'm good.
No,
Yeah.
cool.
These are good questions. These are really good questions.
Yeah, well, there were a few more written ones, but yeah, who's got the next question?
I think up next is going to be Elida Yeni from Stevenson High School.
Yep. Hi, I'm Elida. I'm a freshman at Stevenson. My question to you guys is, what was the most difficult aspect to adapt to when you first started working?
Oh, I got that one. It's joining like a big company. Like I worked at a startup before finishing college, and then after college, I worked at General Motors. And the big kind of shock to me was how messy the systems were and how difficult it was to do something new or interesting. And that's not to say that it doesn't happen. Lots of people will push for and give lots of recognition for using some new innovation or tool. But a lot of the time, especially in a very old company like General Motors, you're working with systems that are 20, 30 years old, and those systems pay the bills. So you're working with these very old tech stacks that need to keep running, and you're trying to balance that with these new and interesting and innovative technologies that are coming out. So kind of that was one of the biggest challenges to me, was to just kind of go through that change in expectations.
If there's anyone here who works at Ford, you may know the term WERS. I think is a great example of the, the ancient systems at some of these large companies, mainframe-based system that they still use for change management. Anyway.
Yeah.
I can go next. One of the challenging things, like in addition to what he just described, was, well, we have a lot of like processes and software development lifecycle, we call it. And one of them is like code reviews, we call it. So you basically like make your code, make your work open for criticism. Like you open it and all of your teammates look at it and criticize. And so it's like, why did you do that? And you should do it this way. So there's a lot of like defending your decisions, also taking criticism, and like managing your time while you're doing that change. If you have to do that change, you know, there's a lot of like you have to build a thick skin to get that criticism, also not be pushed around. So, you know, defend your decisions and stuff. So that takes some time to build, I think, or get used to.
Sure.
Any speaker would like to go next, or?
I'll just throw in really quick that, you know, I think when you first start working, right, I mean, what's difficult to adapt to? I don't think any of this is, you know, what I will say is necessarily unique to computer science or computer engineering or software or whatever. But I think it's you know, you can go in and solve a problem, get work done, you know, be prepared to take some criticism. But I think what I found most is like early in your career, when you're just getting started, is really the opportunity to, you know, learn as much as you can, but do as much as you can. Don't be afraid to make mistakes, right? You can make mistakes, and honestly, as long as you don't crash the system, no one's going to care. So, you know, kind of be a little, you know, smart, adventurous, but smart, right? But then, you know, understand your environment, right? So what's your role? What are the roles of the people around you? What are the roles in management above you, you know, below you, if you're not, you know, starting down at the bottom, right? What are their responsibilities? Network with, you know, being able to just network with people, form relationships. I mean, I try to tell, you know, my son this all the time. You know, the job and advancement is like, you know, at least 50% relationship building, right? It's getting to know people who can do what, you know, leveraging those relationships, leveraging your ecosystem. I'm a fellow, but I don't know everything there is to know about even all of our products, right? So I have to know where to go to get the answers so that I can be the expert in front of the customer, or bring the right experts to bear to solve whatever particular problem it is. You know, technical topics, of course, but more so just, you know, kind of what we always say is leadership, meaning not necessarily that you're the person who is the leader in name, like you're not necessarily the president of Tuckahoe High School chapter, but you behave and act like a leader so that the actual leader in title can rely on you for help or to get things done or to, you know, accomplish the larger team goals, right? So everybody think like a leader, even though you may not have leader in your title. Think and try to behave like a leader. And you do that anywhere. Sorry.
No problem. I just wanted to add, I guess starting up as a, you know, new person at a company, you know, as a college graduate at a company, I guess the hardest thing to figure out is who is who. You know, who do you report to? Who does he report to? What you shouldn't do, and what you should be doing, where you should speak, where you should just hold off until you speak to the person, you know, figuring out, I guess, relationships between, you know, within your team and within, you know, your team and other teams. I mean, I think that is the first thing you're going to be challenged at. You're not going to be, I mean, obviously we all face technical challenges throughout our day because the technology changes when we sleep. But that would be the first, I guess, human challenge for any, you know, any position in any career.
Thank you, speakers. Our next question will come from Daphne Levi from Seaholm High School.
Hi, I'm Daphne, and my question is, what are some common job opportunities for computer engineers?
Okay. Just a clarifying question. Are we talking about computer engineering or like software engineering? I think computer engineering is more on like the hardware, maybe like IoT side of things, or both?
I would say both.
Both. Okay. Well, on the software side, we're all mostly in front of keyboards and like, you know, at a computer throughout the day. So there is some limit on the type of work. Like we're not necessarily out in construction or on site somewhere. But we have opportunities in user interface design, whether we're building applications that people use. It could be like forms or dashboards or visualization tools. There are opportunities on the data side, like if you're interested in big data, like if you want to try and discover interesting patterns in people's behavior and how to turn that into a tool or a service for people to use. I think, Alp, you're talking about an AR tool. That seems like that's an even different opportunity as well. Any other speakers have some thoughts?
I think you have a good cross section right on this panel here, right? If you listen to everybody's bio, right? I mean, we all, I think, you know, a lot of us came at it for, you know, while we're all, I think, pretty much software focused. Mm-hmm. You know, we kind of maybe started down a different path, you know, early in our careers. I mean, I went, you know, I studied specifically computer engineering, but I realized at some point that I enjoyed software more. So I kind of, you know, gravitated toward software development. And that's kind of where I've stayed, and then I've turned that into consulting, right? But I think to answer the question, I mean, I think you can go in a lot of different places. Even once you graduate and get out of college, you can still take it in a lot of different places on the job. I'm going to be very honest. When I went to college, you know, I would say 90% of what I learned, I don't use today, right? And I used to, you know, kids would always say that, well, you know, we're never going to use this. Why do we learn it? It's my experience was a little bit different, I think, than, you know, maybe other, you know, whether it's business or law or whatever, right? It's a little bit different because I think Banu said the technology is constantly changing and evolving. You know, it just changed again 5 minutes ago, right? But you can, you know, if you kind of have the core values, have a technical foundation, right, that you can build off of, and then also have kind of the soft skills, I think that sets you up for success, and a lot of different opportunities, and a lot of cool stuff too. Like you mentioned, David, AR is brand new, IoT is another thing, right? Smart connected products. There's designing the product itself, all these little microcontrollers that are in everything. But then there's the software that kind of gets them all to talk together and sing together, right? So, Caterpillar at one point, for example, was looking at having all of their like equipment on a job site be able to communicate with each other and, I don't know, whatever, do like an excavation in unison, or better yet, communicate with the home base for, maintenance, upcoming maintenance or potential breakdowns or whatever. Just gathering that information. And then I think, like David mentioned, doing the analytics on that is a whole nother area. So, I mean, I could go on and on and on. I think there's a ton of different ways you could go, but establish that foundation and then have a passion, figure out what you really like to do, and then you can go run with it.
Mm-hmm.
So I just wanted to add, graduating with this degree from college, even if you get started as in the software engineering field, 6 months or a year later, you didn't like it. You can always, since you already have the foundation, you could jump to database administration if that's where you find your heart is, or data analytics, data science. There are a lot of things you can do because you already have the base. So yeah, coincidentally, most of us chose software development, but I have friends who are DBAs. So, and we have gone through the same education. So anything could happen once you have the good base.
Yeah, two things that I want to add to the fields is like cloud native approach is like really strong, and there is a lot of demand for, like, they call it cloud engineers. Like we build software in traditional ways, I'll say, and then implementation of that in architecturing, designing systems in the cloud using a specific services or brand services like Amazon's or Google's, Microsoft's. It requires a specific experience and education, which you're not going to get at the school. But as Banu said, like the college education will lay the foundation for that, and you can go ahead and learn on your own with doing a short certification program or something like that. So that's one area of specialization. Another thing I want to mention, like last year in December, I think I I joined online to a quantum computing conference. And I became convinced that quantum computers will be available in about 10 to 15 years. And I think it's very important for you as high schoolers to know about this. So if you really want to build computers, but you think computer technology is old, well, you have quantum computers. And then quantum computing software, like business is looking for that. Like they're like gold diggers right now, looking for the perfect business opportunity. Like what is the quantum computing is best to solve? So that might be an area if you're interested, to explore more.
I think that's a great point. I mean, quantum computing was something I had thought about but forgot to write down. But that in terms of hardware, I mean, that could fundamentally change everything that we do, right?
Right.
There will always be. That's the thing about computer is there will always be opportunities, but you have to be able to adjust and adapt. The same thing that you do when you first start your career may not be the same thing you're doing as you finish it.
Mm-hmm. One thing that really excited me about quantum computing is that they said we are in was that a tube phase, like very, very, very early computer development. Like we are in that phase right now. And business is so ambitious about, making this happen. They are putting a lot of money and resources into it. So I'm pretty convinced that there are really powerful and rich people who are trying to make this happen. So it's an area to look into.
Mm-hmm.
Okay, thank you. And the next question is from Eren Okuju from Plymouth High School.
Hi. So my question is, how is the field of computer engineering expected to change in the next 20 years? And how do you expect your careers to change with that? I guess you guys kind of talked about it with the quantum computers. But, I mean, I guess like anything you guys want to add on to that or talk in more detail?
I guess probably some young people like you are just going to destroy all my expectations about what I think computer science is. That's always how it works. You know, I work with people that are 20 years older than me, and they do just fine. Like, well, some people are. Okay. I mean, so yeah, there's always going to be changes. And like, that's part of the appeal of the field as well, is that it's for people that like don't want to stop learning. Like things are always changing. We're not tying ourselves to any particular frame of mind on how things should be done or will be done for the next 20 or 30 years. So, I mean, like, I guess, like I've been practicing for about 10 years, and probably a big thing that impacted my career in those 10 years was machine learning, data science, big data, that type of stuff. That really picked up steam in the last 10, 20 years, where data just became king. And so as much as you could store, and just hiring academics just to be like, just find interesting things in the data, just hiring interns straight out of college, whatever. Just, we have all this data, just find ways to find it. Because you'll get like 100 data scientists looking at this thing. And if one of them finds an interesting pattern, like at Quicken Loans, that turns into a multi-billion-dollar idea, and that fuels whatever, you know, failed other things were going on with the other 99. So probably got a little bit off from your original question, but any other contributors, please jump in.
I mean, in this industry, I just wanted to say, if you cannot adapt to change, and if you feel overwhelmed with the technology that's changing all the time, unfortunately, that's going, you know, those people will be eliminated or moved off to other jobs that they could deal with. So the next 20 years, I mean, it's all about adapting to change.
Mm-hmm. Yeah, I mean, I think that's absolutely true. And I think, David, you know, one of the the people that are 20 years older than you that are doing just fine, I think I'm probably one of those. But it's interesting when I thought about this, and I started thinking about, okay, well, what are the future technologies that I wrote down? Even the stuff that my company is doing is not anything that I'm doing on a daily basis, right? I mean, PLM, product lifecycle management, was the hot thing 20 years ago. Right, and that is basically all it is how you essentially manage and track, you know, the product structure, the bill of materials for a given product, like, you know, a backhoe loader for Caterpillar, for example, or a warship for the Navy, something like that, right? That was the great thing 20 years ago, and we've been using that software, we've been improving it, right? But we've been doing the same thing for 20 years. Well, in the meantime, things like IoT and SaaS and cloud, like Melis mentioned, are all coming into play here, right? And we're running forward. AR is augmented reality is an additive technology to something like PLM, but it's its own technology as well. Getting all of our tools. So, you know, we started off as a CAD company, as a parametric CAD company, and what we made an acquisition in the last couple of years of a company called Onshape, where they have a pure SaaS in the cloud parametric CAD tool. And I actually have a link I wanted to share with you guys. You can go check it out. And I don't mean to be a shill for my company, but it's cool. It's really cool. At least I think it is. This old guy thinks it's cool, but I think it is cool because it's a CAD tool right in your browser. You don't have to download anything. You don't need Java. You don't need anything. It runs right in your browser. You can explode the model. You can pull it apart. You can rotate it. You can do all this stuff that I don't know how to do because I don't know anything about CAD. But it's really cool, and that's just one thing. You know, like I said, Internet of Things is another area where we've invested heavily, right? We want to be the software that kind of manages all those smart connected products, all those, you know, backhoe loaders, or the different pumps pumps at like a waste treatment facility, whatever. The future, though, I think the one thing I'll leave you guys with is, solving real world problems, right? So whatever the problems are, being able to solve those real world problems with software and hardware, I think is where the future will take the field of computer engineering and computer science.
Dad, if you want, you can put those links in the chat for both the Google Slides and the thing, so people can look at them. But
yeah, I would highly recommend it. It's pretty cool. There's a number of other things as well. There's links to like free software, all the stuff I shared with you last year. You can download education versions of some of our software, and there's training that's really good. I've gone through some of it myself as well. So, but okay, I will share that. Yeah.
So for the last question from our students is from Yeliz Bulbul from Northville High School.
Hi, I'm Yeliz Bulbul, and my question for you guys is, what advice do you have for high school students interested in the computer science field?
I feel like so many. Where to start?
Be a doctor. No, I'm kidding. I wouldn't be a Turkish dad if I didn't say that.
Not Indian.
No, apparently we share things in common. I don't know, but I heard that all the time. So
I think math helped me tremendously. And my background was another engineering degree, had nothing to do with software engineering, and critical thinking kind of was played a major role in becoming successful in software engineering.
Yeah, I want to talk a little bit more about what you just said, Bana, because we keep saying this to people, right? The math is so important. I mean, I was thinking about that the other day. We are formulating problems every day, all day long. We run into problems and then we say, oh, the problem is this is not working. And then what we do is to find what is not working and then create a pattern, right? If I do this, then this is not working, and kind of create that abstract formula and find what's missing. And most of the time, 99% of the time, Google has the answer today. But your real skill is to create that abstract formula and create a good question, ask a good question. So that's the real skill that you have to build.
Yeah.
That's why math is so important. It doesn't matter if you studied mechanical engineering or physics. If you have that math skill, it'll help you tremendously.
Right.
I'll go a little different direction on my advice, and that actually goes back to I think something that's been said before, but the work experience is you're going to learn more your first year of work than you will have felt that you learned your entire college career. So if you can get into any internships in college, that's just going to be, if you can do summer internships, probably starting as soon as like your sophomore summer, I would think that would be a really, really valuable experience. You're going to really start to relate. I remember when I was doing my undergrad, I had such a hard time understanding how writing for loops and if statements and things like that were going to convert into something that people used that was valuable. So getting that work experience and tying your academic experience to providing value to people is not just going to make you a better potential employee when you're interviewing, but it's also just going to help tie the threads of why are you learning these things and why are they important.
I want. Go ahead, Bana.
Oh, go ahead. Sorry, I was just going to say it also ties back to our statement about developing your network. When you're an intern, you're introduced to the company. You get to know a few people. A couple years down the road, you apply for a job and they already know you.
Mm-hmm.
I wanted to make a little bit focus on the college education, because like we all say like, oh, we don't use all the things that we learned or that we use whatever. But I've something that I think is, and we see every day, in the software development area, we see a lot of like second career people. So this is not their first career. Like they did a boot camp or took some online classes, and now they're in software development. And you don't have to go to college. That's my own opinion. You don't have to go to college to learn to program.
But go to college.
But you will go to college. You will go to college, right? It's not like you're going to skip to be a software engineer. My advice is do something different, because programming is used in every field right now, in genetics, history, anthropology. Like find those, what's that called? Like interdisciplinary research areas wherever you go. Find, professors who's interested in doing like different things, like analytics or writing some sort of software to solve a problem, and work with those people. And those were the most fun times that I had in my educational life. You don't find those opportunities very easily once you start working. Once you start working, it's all about, we were doing this manually, now we want to do this programmatically so we can do it faster, hence we save money. That this is what we're doing right now. So college is your time to do that, like really interesting, awesome, cool stuff.
Yeah, that's the value of college. Yeah, building those networks, exercising your autonomy.
Yeah, focus on that. Don't be like, oh, I'm not going to use this. You'll use it.
Yeah, I mean, I think that was from my perspective, it was the big thing that I got out of college was learning how to be a kind of a professional, not student, but how to behave how to be a professional, right? Everything is not laid out for you to follow the directions and do this and do that. Don't focus. I love your advice, Melis. Don't just focus on being the programmer, right? Solve what are the problems that you're solving with the software? The software is a tool to solve a problem. Exactly. Go find the problems to solve. That's really fantastic advice. Right. And that's that's the thing to take advantage of when you're in college. And then also like David said, to leverage those internships if you can, because like Manu said, it's the networking, and it's but even if you don't end up working for that company, right, long term, you understand kind of what the work environment is like, what the expectations are, what people want you to do. Again, there's not a guide telling you step by step what to do. You got to go figure it out. Or maybe there is a guide, you just got to go find it. You don't know where it is, right? And you have to apply yourself, right? And that's I think that's the value. So learn all the tools, learn the software, learn Java, learn a database, whatever. Yeah, that's all important. But think and act like a leader. Take responsibility, take ownership of whatever it is you're doing, and kind of treat it like it's the most important thing.
Yeah.
Right.
Thank you.
Okay, so now we're going to transition to the chat questions. So you can either unmute yourself and ask the question yourself, or Elida will read the questions from the chat if it is not asked. So
we have a few questions in the chat. Our first one, let's see, comes from Deniz Karya Achikbash, and they're wondering, what IDE or integrated development kit do you guys use?
IntelliJ.
Alp, I saw your answer. Just you're weird. And
oh, hold on. I edit with VI as well. So
I love VI.
Vim on Windows, but it's still VI.
Oh, you're cool.
Okay, don't look at me.
You're really weird.
I don't do enough development anymore. So
yeah.
Okay.
Vim on Windows. Wow. So I use you'll find yourselves using command line interfaces quite a bit. So get comfortable with those.
Yeah.
You don't have to use Java
Yeah.
C like Alp does, but
It still works.
it's good to know it. It's good to know it. We both use IntelliJ a lot. I also really like VS Code, Visual Studio Code. I find it a very lightweight yet very extendable IDE.
I guess it depends on which technology stack you're using. For most of us at my work, it's either IntelliJ or Eclipse, but command line definitely is used.
Yeah.
And for the people I work with that know what they're doing, they use Eclipse, by the way. So
that reminds me, in my first job, I used no IDE. I wrote Java code with, yes.
Yeah.
So it was painful, and it wasn't that old. It's just the company. But anyways, yeah, Terminal and IntelliJ for me.
Thank you, guys. Our next question comes from Yenar Yin. It's a bit long. What department does one go to for a formal education? Some schools have computer engineering departments. Some have computer and electrical engineering. There is computer science, and there is computer science and engineering. What kind of expertise or field of work is to be expected from graduating from these slightly different schools? If you guys could keep your replies to at least a minute, that would be highly great.
Yeah. Okay.
this is like the Grammys.
Yeah.
If you don't keep it to a minute, they're going to start playing the music.
You can take my minute. I don't have an undergrad degree from here, so.
Yeah, I'm gonna. So, so when at Michigan, we had computer engineering and computer science were separate, but there was a lot of overlap, right? And I think David or Melis mentioned it as well. I mean, computer engineering is kind of the hardware side of it, and there's electrical engineering concepts and principles that you use. But and guys, remember, I mean, this is 30 years ago for me. Yeah, 30 years ago. It was computer engineering. The engineering piece of it was chip design, AND gates and OR gates and all that stuff, and then the electrical behind it. Right now, we're looking at things like quantum computing. So that's kind of the engineering. That's hardware. That's, do you go work for Intel and work on the next i7 processor, and then computer science is the application of computers to problems mostly focused on software. And then of course, software is like a massive broad field as well. So, I would, again, I think of it in terms of hardware and software. Mm-hmm. One is hardware, one is software, but.
Yeah, I would just say that the specific program and degree may not matter so much after, say, your first year of work experience. Like, you're just trying to get your foot in the door with that engineering degree or with that tech degree. Beyond that, you're going to have a lot of opportunities to branch out in different directions or go back to school for a master's degree when you figure a little bit more out about your long-term goals. Just don't sweat too much about, oh, is this School of Science and Engineering? Is this, this type of, department or program? I mean, go to a good school, go to a decent school. But I mean, even some of the best programmers I've ever worked with just come from no-name universities.
Exactly,
they just really love the
yes.
program. So,
Right.
it's really going back to, exercise your networking, exercise your leadership skills, exercise your autonomy, your decision-making. Yeah. Those are what's going to be those big drivers of your long-term success.
Yeah, I mean, it sounds like you'll have to look into the coursework and see what program offers what. And if you know what you don't want to spend your time on, that might be a criteria for you to choose. And if you don't have any idea, I would go for the most diversity, like a little bit hardware, a little bit software, a little bit database, whatever they offer. It won't hurt.
Thank you. We have a lot of questions here, so we're just going to say that real fast. This one comes from Mehmet Tasçoğlu. For the panelists to know the difference between AP Computer Science Principles and AP Computer Science A, which one would you recommend high schoolers take?
Oh, that's you. What? AP.
Yeah, so I saw that one. Mehmet, I mean, can you explain, like, I do this with Eren. Okay, what is the course outline say?
Yeah.
What's in it?
Yeah.
Yeah,
And
I'd
we
have
can help
to
you
see
figure it out.
Science principles.
Because
I'm
obviously, when I was in
guessing-
high school, we had no such things.
Yeah, I'm guessing principles is more of like a high level view, or maybe, yeah, we would really need to know a bit more about the course outline or the
Oh, I
syllabi.
can answer that. It seems like if you're going to be a software manager, go with the science principles. If you're going to be a software developer, go with the computer science. I'm joking, of course, but that's the first thought that I had when I saw the principles there.
I will say try and code while you're in high school.
Right.
That's going to, because when you get to college, it's just going to be a big burden off your back if you can code in high school.
Yeah, they don't teach you how to code in college. You're expected to know how to code. So I think, and you had the question, how did you learn the languages you use? I learned it all on my own. I mean, yeah, there was a course here or there or something, but I didn't take a program.
Oh, there's the outlines.
Oh.
So it's you learn it. And so you guys are lucky too, because Java is so pervasive. And if you understand Java, you can go learn other languages as well, or at least feel comfortable understanding them. So if you want to learn a language, I would say, Java is a great one.
Wow, I see the outlines and I still don't have a better answer.
Oh.
They both look excellent, honestly.
Yeah, I mean, that looks pretty good.
Yeah.
Oh, this one has like computer systems and networks, fault tolerance. It's a bit more like on the network
Well, it's
side.
pretty broad, like data, creative development, ethics.
Those are good. Those are all good topics.
I almost say principles just because that's going to be very broad and that's going to give you the background to decide where you might want to focus more.
Although I wouldn't be a good computer person if I didn't say do both.
Yeah, there you go. Yeah.
How very
Why
consultant
choose?
of you.
I know. I'm sorry.
I think we quickly skimmed over Eden's question. Would you like me to read that one again, or should we move on? Because we're running a little low on time.
I mean, could I just really quickly hear the other panelists' answers
Yes,
as
of
well, just real quick?
So, how did you learn all the languages you use today? Was it in school, taught, or in the work environment?
Started in high school, where you really do learn about the very basic programming constructs. And then it's like, there's an old joke about like, it's like paint. It's just different colors of paint. It's like a job posting, they're not going to say, we're looking for people that paint with the color brown. It's like, well, I've painted with these different types of paint and I can paint with a different color if you want. So after, you start using 3, 4, 5, 6 different languages to solve your problems, it's just like, all right, what's the next one? They all have their differences. They all have their pros and cons. You really start to be able to pick them up on the fly, but at the same time, you want to do a good job and you will need to spend a little extra time, learning the nuances and making sure that you're using it effectively. And that can either be on your personal time or a good employer will also sponsor training or education for you.
Yeah, I took a C class at college. I found it very difficult. I want to say this to all of you so that you won't give up at your first try. I just stick with it because I couldn't accept not being good at something. So I was in solar car team that gave me a lot of opportunities to like do practice. And then after college, I kind of taught myself Java. And again, like since I had no formal object-oriented training, I found it miserable and couldn't really understand what was going on under the hood until I took a compiler construction class, which helped me a lot. And then I learned JavaScript on the job. I had no JavaScript experience. And yeah, that's kind of how I learned different languages.
So on my end, when I was in the graduate program, they were offering C++ and advanced C++ classes for us. And industry at the time was, you know, a lot of Java development. So, and I realized they weren't ready to offer Java to the, you know, to the students at the time. That no one was teaching it that I could, you know, I could enroll into. So I took a different path. I went to a community college as a graduate student, and I took a few classes from community college. And actually, when I started my job, I was still in the middle of my class. I mean, I was still taking the class, finishing up.
Oh.
Thank you, panelists. I believe our time is up, so I'll be handing the floor back to Mehmet.
Okay, thank you, Elida. This webinar seemed really active. We had a really engaging chat. I mean, that's no surprise. There are 4 computer engineers on the webinar, but we are out of time, so we're gonna conclude this webinar today. If there's a question that you had that you want to answer really bad, maybe that you can afterwards, we conclude it. I want to thank the Tucum board, the Tucum Education and Outreach Committee, the Tucum High School Chapter board, and we want to thank all 4 panelists, Mr. Akujo, Mrs. Arslan, and Mr. and Mrs. Kaczynski, for taking your time in this Sunday today to come speak. But I think we're going to conclude. So yeah, thank you for coming.
It's been a pleasure. Thanks for having us.
Thank you.
Okay.
Thank you.
To reach out on LinkedIn and
Yeah.
ask any question that you have in the future. We'll be happy to answer.
Yeah,
We're
absolutely.
around.
Absolutely. Yeah. You guys know where to find us. And we had, our esteemed friend Kiremali was on as well. And we should have, he's another great resource. So disappointed we didn't get to talk to him too. Hi, Kiremali. How are you?
Doing well. It was a great webinar, guys. Thanks so much for attending.
You can tell us what I said wrong, Kiremali.
You're all right. You're all right.
All right. Bye.
All right, bye everyone.
Bye.